Welcome to The Explainer. Today, we're going to be talking about something that's all around us, but a lot of the time totally unseen: pollution. It's in the air we breathe, the water we drink, even the ground right under our feet. So let's make the invisible visible. We're going to uncover what it is, where it's all coming from, and most importantly, how we can start to fight back. Okay, so to really get this, let's start with a sense of scale because, the biggest threats are often the ones we can't even see. This thick line you're looking at, that represents a single human hair. Now, look at those tiny dots. Those are particles of pollution. The bigger ones, we call them PM10, they're small enough to get into your throat and upper lungs. But the real danger, well, that's PM 2.5. These particles are so incredibly small, they can get lodged deep, deep inside your lungs. And some research is even looking into PM 1.0 particles, which might be tiny enough to pass right into our bloodstream. I mean, this is what we're up against, an enemy so small it just walks right past our body's natural defenses. All right, to get our heads around this invisible intruder, we're going to break this explainer down into 4 key parts. First up, we'll get a clear diagnosis of what pollution actually is. Then, we'll map the invasion to see just how widespread it's become. After that, we'll calculate the true cost of all the damage. And finally, we'll get into the counterattack, what we can actually do to fight back.
So let's dive into part 1, the diagnosis. First things first, let's get a really clear idea of what we're talking about when we use that word pollution.
At its very core, pollution is just about harmful stuff that's out of place. It's not just big clouds of factory smoke. A pollutant is really any material that's in the wrong place, in the wrong amount, and it's causing damage. Sure, it can come from natural sources, like ash from a volcano, but the kind we're really concerned with is what we call anthropogenic, which is just a fancy way of saying human-caused pollution. Now, this is really interesting. We can basically split pollutants into 2 main camps: the stuff nature can handle and the stuff it just can't. Biodegradable pollutants, like your kitchen scraps or a piece of paper, are basically food for nature's cleanup crew, the decomposers like bacteria and fungi. They've got the right tools, the right enzymes to break this stuff down. But then you've got the non-biodegradable pollutants, like plastics. Nature's decomposers just don't have the tools for that. So what happens? They just stick around. They accumulate in the environment for hundreds, sometimes even thousands of years. And this intruder, it doesn't just stick to one place. It invades every single part of our environment. We usually think of air, water, and land pollution, and yeah, we're going to focus on those, but it's so important to remember that pollution also takes other forms like excessive noise, harmful radiation, and even thermal pollution, where just adding excess heat to water can completely disrupt an entire aquatic ecosystem.
Okay, on to part 2, mapping the invasion. Let's take a quick tour and see just how widespread this problem really is, focusing on our planet's 3 big arenas: the air, the water, and the soil.
So our first stop is the air. Air pollution is by far the most mobile form of this intruder. I mean, a cloud of pollution released in one city can cross state lines or even international borders in just a matter of hours. The smog we see choking our cities is this complex cocktail of primary pollutants, that stuff shot directly from a source, like carbon monoxide from a car's exhaust. And then you have secondary pollutants. These are created when those primary pollutants react with each other up in the atmosphere, creating totally new dangers like ground-level ozone and even acid rain. Next up, our water. As this slide shows, pollutants get into our waterways in 2 main ways. First, you have point sources. These are easy to spot, like a discharge pipe coming straight out of a factory. But then you have non-point or diffuse sources, and these are so much harder to control. Think about fertilizers and pesticides washing off a huge farm every time it rains, or all the chemicals washing off city streets. Both create this silent crisis that's happening right underneath the surface. And finally, we have this soil. Now, unlike air pollution that travels everywhere, soil pollution is the most immobile form. A chemical spill or a pile of industrial waste, it tends to just stay put. Our land becomes this dumping ground for trash, for industrial byproducts, for agricultural chemicals. But here's the thing: immobile does not mean safe. These contaminants can totally destroy the soil's fertility, and as rainwater seeps through all that waste, it can carry those pollutants down into our groundwater, poisoning the drinking water for entire communities. Okay, let's get into part 3, calculating the damage. We've seen how the invasion works, but what's the actual damage report? Let's try to calculate the cost, and not just in environmental terms, but in human lives and in real economic losses. Let's just start with a number that's, well, it's hard to even wrap your head around: 7 million. According to the World Health Organization, that's the estimated number of people who die prematurely every single year from air pollution. Let me put that in perspective for you. That is more than the deaths from AIDS, tuberculosis, and malaria combined. It is a staggering public health crisis that is happening all around us every single day.
And this diagram right here shows us exactly why. Our respiratory system is ground zero for this attack. Deep inside our lungs, we have these tiny little air sacs called alveoli. It's where oxygen actually enters our blood. Well, those tiny PM2.5 particles we talked about earlier, they get lodged right here, causing all sorts of inflammation and damage. This doesn't just lead to breathing problems, it forces the heart to work way harder, leading to really serious cardiovascular diseases.
The cost to the environment is just as devastating. This slide shows a classic tragic example called eutrophication. It all starts when nutrient-rich pollutants, like fertilizers from farms, get into a lake or a river. This flood of nutrients causes an explosive growth of algae. We call it an algae bloom. But when those nutrients get used up, that massive algae population dies and sinks to the bottom. Then, bacteria move in to decompose all that dead stuff. And in the process, they use up nearly all the oxygen in the water. This starves the fish and everything else, turning what was once a thriving ecosystem into a sterile dead zone. So the key takeaway here is that pollution isn't just a health issue or an environmental issue. It is a full-blown economic crisis. When people get sick, they can't work. That strains our healthcare systems and tanks productivity. Agriculture suffers immensely. In some polluted areas of India, crop yields were cut in half in just 30 years. Even our beautiful historical monuments are paying the price, as acid rain slowly eats away at stone and marble, literally erasing our history. Which brings us to part 4, the counterattack. Okay, facing a problem this huge can feel, well, pretty overwhelming. But a multi-pronged counterattack is already happening, and it involves individuals, technology, and government policy all working together. And it really does start with us on an individual level. The 3 R's are such a powerful framework. Reduce, simply buy and consume less stuff. Reuse, find new ways to use things instead of just tossing them out. And recycle, sort your waste so those materials can be turned into new products. Some people even add a 4th R, refuse. Just refuse to buy things you don't really need, which tackles the root cause of all this consumer waste right at the source. But personal action has to be backed up by big systemic solutions, like the sewage treatment plant. You can think of it like a multi-stage factory for cleaning water. First, it screens out all the large debris. Then it lets the solids settle out. After that, it actually uses helpful bacteria to digest all the organic pollutants. And finally, the water is disinfected before it's clean enough to be released back into the environment. It's an incredible process. Ultimately, the fight requires this powerful combination of technology, policy, and infrastructure. We need strong policies, like actually enforcing air quality standards. We need cleaner technology, everything from catalytic converters in old cars to brand new electric vehicles. And we need smart urban planning. For example, the city of Delhi built a world-class metro system and now runs the world's largest fleet of buses on cleaner natural gas. Those are the kind of systemic changes that clean the air for millions of people at once. And we have these absolutely tragic reminders of why these policies and regulations aren't just suggestions. They are a matter of life and death. In 1984, a leak of incredibly toxic gas from a pesticide plant in Bhopal, India, killed thousands of people overnight. It left hundreds of thousands more with permanent, devastating injuries. It was a complete, catastrophic failure of safety systems, all due to negligence. Bhopal is this permanent scar that reminds us of the horrific human cost of cutting corners and why it's absolutely necessary to hold industries accountable. So, this leaves us with a final thought to chew on. This massive, global problem is really just the sum of countless local actions: the car you choose to drive, the products you buy, the policies you vote for or support. So the question is, since this whole problem is built from so many small parts, which small part can you influence starting tomorrow?